Hello everyone, welcome to SISCOOL Digital Classroom. Science is cool. In today's video, we will learn about the critical angle in the simplest and most practical way. Once we understand the concept clearly, solving related numerical problems will become much easier. We will begin with a small experiment. For this, we have a semicircular glass slab and a light source that produces a narrow beam of light. The light beam enters the glass slab, travels through it, and then emerges into the air on the other side. To measure the angle of incidence and refraction, we will use a circular scale marked in degrees. When the light ray enters the glass slab from air, its angle of incidence at the surface is 0 degrees. So the light passes straight through without any deviation. However, when the light exits from the glass into air, the situation changes. Because here the angle of incidence is not 0. Here the light travels from a denser medium, glass, to a rarer medium, air. In this case, the angle of refraction is greater than the angle of incidence. Now, let's gradually move and rotate the light source so that the angle of incidence at the point of entry on the glass air boundary, point O on surface XY, starts increasing from 0 degree. So let's start. Now we can observe that as the angle of incidence increases, the angle of refraction also increases, and it increases faster than the angle of incidence. At a certain point, when the angle of incidence is around 41.8 degree, the refracted ray just grazes along the surface, meaning it travels exactly along the boundary between the glass and air. If you observe the scale, you will see that the angle of refraction here is 90 degree and the corresponding angle of incidence is about 41.8 degree. This particular angle of incidence at which the angle of refraction becomes 90 degree is called the critical angle for the two media, in this case glass and air. So the critical angle is the angle of incidence in the denser medium for which the angle of refraction in the rarer medium is 90 degree. It is important to remember that the value of the critical angle depends on the pair of medium, here glass and air, and the color or wavelength of the light used. If either of these factor changes, the critical angle will also changes. Now, if we further increases the angle of incidence beyond 41.8 degree, the light no longer refracts out into the air. Instead, it is completely reflected back into the glass medium. This phenomenon, where the light reflects entirely inside the denser medium, is known as total internal reflection. So, to summarize, when light passes from a denser to a rarer medium and the angle of incidence exceeds the critical angle, total internal reflections occur. The critical angle marks the exact point where refractions turn into reflection. In this video, we learn about the concept of the critical angle and how it leads to total internal reflection. Now, you should go through your textbook and practice some numerical problem to strengthen your understanding. Thank you all for watching and keep learning.